Welcome, everyone. Hello. Hello. They gave me the session after lunch. Who had a hot dog? Who went out and had a proper lunch? I'm not saying the hot dog wasn't proper. I'm just saying that, Anyway, welcome to this talk on Exposed. How many of you here have seen Exposed or know about Exposed? Okay, great. So I'm going to give you an overview of Exposed. We're going to see kind of enough for you to understand what it is, and then if you're interested to start working with it. We're going to start with where the story a little bit about how Exposed starts. So this is the website for Exposed. This is the website for Exposed. That's an overstatement. This is the GitHub page for Exposed. The website is coming, and there's a label here which is called Team, JetBrains Team. So does anyone know what the label means? It means don't use. But apparently people don't listen. So this is a label that we classify at JetBrains, which is like, this is a project that we are using on some things internally at JetBrains, and it's okay for us to kind of make it open source and throw it out there. Use at your own will, and apparently a lot of people, both inside JetBrains and outside of JetBrains, started using it. And this turned into a project that is being used by thousands of developers worldwide. Well, thousands. I don't know how many developers are using this. I know there's over 1,000 people on the Kotlin Slack, so there you go, at least 1,000 people. And it's being used inside JetBrains to power much of our software, including all of those things with subscriptions and payments and even Space, our product, is using Exposed under the covers. And as any good open source software, is maintained by 1%, 20% of the time, right? So we'll change that. I'll give you some updates on that. But the point about this is that don't worry about that label anymore. That label has not been updated. It is now JetBrains Official, which means you can officially use it or unofficially. And it will be maintained, and it will be supported, and it will be continued. So there you go. Now, Exposed, the mascot is a cuttlefish. I have no idea why. There's an explanation in here in that the cuttlefish is well known for its outstanding mimicry ability that it enables to blend seamlessly in any environment. In other words, there's a reason why developers don't do good marketing, because you could say that about anything. But hey, it's a cuttlefish, so there you go. Right, so what is Exposed? Exposed is a lightweight library framework that allows you to work with data. And it is written purely in Kotlin. It is magic-free, meaning there is no annotations as such. So everything that you do, you kind of see what you're doing. And I stress the point that it's lightweight, because nobody would ever present a library and say, well, I've got a really heavyweight library that I'm going to talk to you about. To be honest, though, I asked folks on the Exposed channel, like, why do they use Exposed? And they said it's lightweight. And then I asked, what do you mean by lightweight? Well, I don't know. Why are you asking me difficult questions? It's lightweight. It's just like there's this meter that says, is this lightweight? Yes, okay, I'll use it. Is this heavyweight? Yes, then I won't use it. But anyway, it's lightweight, and Exposed comes in two flavors. So you can mix and match these. One of them is a Kotlin DSL, which essentially means that I can use Exposed to access SQL using statically typed language, which is Kotlin. So instead of me writing SQL in strings, I can basically write it in Kotlin, and then that gets translated into strings. And the other flavor of Exposed is this thing called the DAO, which is Data Access Object, which is kind of a lightweight ORM. And allowing you to basically define your classes, and then having those classes load and read and store data and manipulate data directly with that. So I'm going to show you a little bit about how it works, and we're going to examine both flavors and then how you can kind of like combine these in your applications. So let's start with the very basic. I'm not going to ask you if you can see the font at the very top, because if you can't, then there's loads of seats down here. You should have been sitting here. But hopefully you can anyway. So this is where it all starts with the database. I have a database running in a Docker container here, which I'm going to be using throughout most of this demonstration, which is a Postgres database. And this is essentially what it does, is connect to a database. Now, the reality is that this doesn't actually connect to a database. It gets ready for a connection as soon as you want to start doing transactions on this. So what you can now do from here is, let's say I want to connect to a database and I want to create a table. I want to create something. So let's go ahead and first take a look at some table that we may have, right? So we can look at, for example, speakers. So I have a speakers table, and this is how you define your table for Exposed to then understand. You define it as an object, which is for folks. Okay, let me take a step back. Everybody here knows Kotlin, right? Yes? Okay, that thing you use for Android? No. Okay. Anyone here that doesn't do Android development? Just me? Okay. Right. So you define your table using an object. So here I have a speakers table which inherits from table, right? And I define the fields in the columns that my table is going to have. So it's going to have an ID with UUID. I know, don't kill me. Let's just pretend that it's okay to have UUIDs. I have a name, I have a bio, and I have a Twitter. You can see that basically for each type here, so if I say, for example, X, I can have an integer or I can have different types. And then this maps to the actual database type that you're working with. You can set default values. You can say, for example, something is nullable so that it can admit nulls. And then at the bottom, you can see that I have this primary key, which I'm defining my primary key. Now, usually if you have an ID table with an integer, there's a shortcut to this, which we'll see later on, which allows you to basically define a different type of inherit from a different type of table, so you don't have to be explicit about the primary key. So here I basically have a speakers table. And now how do I start working with Exposed? If I go back to my basics here, what I can do is anything that I do in Exposed, I have to wrap in a transaction. Right? So this is essentially a higher order function in Kotlin, which is a transaction. And you might notice that there is no parameter in terms of the database. Now, this is kind of a thing that some people like, some people don't like. But by default, Exposed is going to look for the default database, which is going to set it up and assume that you're using the default database defined by this database connection. So you don't have to be passing the database around all the time. Later on, we'll see that there's a way for you to explicitly pass this around, but if you do not, then it's going to default to the default database. So, and I'll say default one more time. So now what I want to do, the first thing you want to do with Exposed is create your table, right? Let's say that I'm starting with a new application and I've got a new object that I want to store data from. How do I actually create that table? So you have this thing called schema utils, which if we go to, you see that it's an object with a whole bunch of methods. And on here, you can say create, and then you put the name of the table that you want to create. So for my case, I want to create speakers, right? And then I import that speakers. And then if I run this, what it's going to do is it's going to connect to the database, create that table for my speakers. If the table exists, it will do a check, so it's not going to recreate a table. If you want to drop a table, there's a method for schema utils also that's called drop, which allows you to drop the table first. And we'll see some other things you can do with schema tables later. Now I'm going to add a logger here so that you can see some of the things that this is. Where's my logger? So most of the code that you see here is going to have a logger, which is going to show the output. And let me just run that, right? And you see there's no output, and my logger doesn't work. Doesn't matter. We'll see the logger later on. That's the beauty of doing live coding. But if you see that statement, it usually works. So, Hadi, I told you should have checked this. Oh, shut up. Anyway, no, jokes aside, let's go to the logger. So if we do logging here, you can see that I actually have some logging. So this logger is down there, and yeah, we'll show you this in a moment. So this is the basic thing you can start to do with exposed. You essentially connect into a database, starting a transaction. By default, the transaction is always going to commit. There is a rollback. If you want to roll back, you can explicitly roll back. You can have nested transactions. But generally, the way that you operate is I open a transaction, do whatever I want to do, and close my transaction. So now let's go ahead and insert some data. In this case, I have smoking recipes, which is barbecue. It's got nothing to do with the other type of smoking. So I have a bunch of fields here, which is the produce that I'm going to smoke, temperature at which it is, whether or not it needs wrapping. Oh, sorry, I'm a big fan of barbecue, so just ignore me. Also, I really lack imagination. So the first thing that came to my mind was barbecue table, so I did a thing about barbecue. And wrapping material. Also, I live in Spain. I know this F thing is strange. Normally, just like in France, we do Celsius, but when it comes to barbecue, you have to use Fahrenheit. So here I have some code that what it's going to do is insert data into my database. Now you notice that I have a new function called connect. What is that function? That's basically what I just showed you, except I've made a function out of it so that I can easily reuse it across these samples. Then I have my transactions, I create my smoking recipes, and now I have a function on my smoking recipes which is called insert, as you can see. So I have insert, I have delete, I have update, etc. Now we're focusing on the insert. And then on the insert, I say, okay, well, what is the parameter that is passing to? It's the actual instance that I want to insert, the object, and then I'm going to provide the values for each of these fields that I want to set, and then essentially it will insert those. So it's going to run these two, and then it's going to commit by default at the end with the transaction, and you can see that that is essentially inserting it. Now, you're not seeing it because there's nothing that's showing there, but if I go to the database console, and if we open up, for example, my smoking recipes, you can see that I have just inserted a bunch more. Now you'll say, but Hadi, you had those before. How do we know? Oh, really? You don't trust me, do you? Okay, fine. I'll run it again. You see? Did that show up? Did that show up? There you go. Oh, okay. This is going to go really bad from now on if this doesn't work. So yes, so you can see that it's inserted the pork butt. So what is this? This is basically what I'm talking to you about with regards to the SQL DSL, right? It's essentially an idea that I can do SQL in my code without having to write strings or writing SQL code as such, but more using Kotlin. Now you can do other things as well, like for example, a batch insert. So in the batch insert here, what I'm doing is essentially using the abilities of the database to do batch inserts. That's where the name comes from. And here what I'm doing is reading a list of speakers, then I'm reading a list of, and in fact what I'm going to do is I'm going to delete the speakers and the talks so that we can see that this actually works, right? So I have my connection as we saw before. This is just a library that I'm using, which is called something I found on the internet, which is CVS Reader, which essentially is taking these files that we have, which is speakers.cvs, which is a bunch of comma separated values, and it is parsing those into a list, and then I'm going to add them to the database. Okay? And I'm going to do a batch insert. So if I were to run this, you can see that I get my standard SQL output, and it's showing that it's doing a whole bunch of inserts, right? So for each one, it is running an insert, and it's executing it in the database, and then if we open up the database console and we refresh it, we can see that we've got our new tables here, and we can open up the speakers, and we can see all of the speakers that have worked. You see, sometimes things work. So now that actually isn't taking advantage of one of the features that databases usually have, which is when they want to insert values, for example in Postgres, you want to do it in the most efficient way that the database allows you to. And there is an option that you can pass, but this is not specific to exposed. This is specific to the database. That's why there is no kind of functionality inherent to it in Expose itself. But when you're doing batch inserts, you want to try and understand what your database supports and then use the corresponding configuration for that database or the parameters. In the case of in the case of Postgres, you have to pass in a parameter which is called write batch inserts. And if you do this and if you run it and if you test it, you'll see that it drastically cuts by half the amount of time it takes to insert things into the database. So batch insert allows you to do it from the Expose side, but you do have to fine-tune it based on the database that you're using. So you want to be able to update stuff as well, right? So how do we update stuff? Well, now it becomes very simple. Here I have my talks object again. The talks, again, here is just the object which represents the database. It's not an instance or anything. It's just that singleton object that represents the database. And it is calling update on it. And in the update, I'm passing in the condition of what rows I want to update. And this is where it gets a little bit weird. And I'll comment on this in a moment when we see some queries. And then I just set the value that I want to update. And again, since this is in the transaction, it will just execute that and will commit it as a result unless something goes wrong. With delete, it's exactly the same. I write delete where, and then I pass in the parameter. Again, a little bit inconsistency there when we come in regards to the API. Right? But let's go to the queries, which is where it sort of kind of gets interesting here. Because normally with SQL, what you want to do is write queries. Okay? So your most simple query, select talks description equals empty. What is equal? Well, this is an infix function, which there's a whole bunch of operators that Exposed offers. You have equal, not equal, contains, etc., which essentially are mapping to the ones that are available in SQL. And then basically what this is doing is selecting all the talks from my database. It's giving me back a list of talks onto which I can now loop and say, okay, for each talk, I want you to print out the title or what have you. Here's one thing that you might find strange. Why is the select passing in the condition? This is somewhat awkward because in select you would normally want to maybe first say select the columns that I want to select and then where, etc. So here is a little bit different, and in fact Exposed is a 0.4. We haven't ever released a 1.0, and we're right now looking at seeing whether it is time before we release a 1.0 to clean up a little bit the API and make it a little bit more consistent with actual SQL. Because now it's kind of like a little bit of SQL here, a little bit of not SQL there, etc. If I want to do other things like, for example, select a single column, so I use the term slice, which is in database terms, means you slice up the database into columns, and then I say, for example, so the above one that we saw would be a select star, whereas this one would be something like select talks, title, or select title in this case, right? There's no talk. Select title, and then from the actual database. So we can see that here, first I'm defining the columns that I want to select, and then the condition, and then again I get back a result of values, and I can loop over those values. You can do more complex things, such as, for example, joins. So you got inner joins, outer joins, etc. So here I have two tables, which is talks and speakers, which are mapped via foreign key. And I'm going to do a talks inner join with speakers. I select the actual fields that I want to get back. I select the condition. And then again, on that, I can start operating with the results. And if we were to run all of these examples, you'll get back a whole bunch of data, which we'll see. So you see all of the different values from all of the different queries are coming back here. Now, in this last line here, there's an interesting one, which is, by the way, this condition is just to show you an example of how you work with null. You can essentially use null as well as you would usually. So this example here is showing you, like, how does this actually affect in the database? In this case, what I'm doing is I'm saying on all the talks, give me all of the talks back, and then I can even limit, for example, if you're doing pagination, and then I can do an items count, right? In this case, I can do, for example, a select, all, count, etc. And if we run this, as we saw, you saw that one of them is select, count, whatever, from select, blah, blah, blah. The other one is select, count, from talks. And you would wonder, okay, well, does that actually have any kind of impact, right? So if we go to the query console, what you could do is you could take this output and paste it there. And then you can add the explain in front of it, which will show you what the database is actually doing. And you can see the query plan for the database, and you can see that basically it's doing a single scan, right? Now, if we take the other example over here, which was from the run window. Where's my run window? Where's my run window? Oh, bloody hell. You know what? I'm going to run this crap again. Select that. Go to my query console and put an explain in front of that one. And run this one. You can see again that it's doing a single scan. So because many databases actually know how to do these optimizations. You don't have to worry about that so much. But it is something to take into account. You need to know what your database is capable of and what is not. And Exposed, of course, works with a variety of databases. It works with H2, with MySQL, it works with Postgres, it works with Oracle, a bunch of other ones, right? And there's a common interface to those. But then sometimes how your database acts under the covers is going to vary. So you need to be aware of that. And then we have the ability, in addition to doing everything that Exposed offers you through the DSL interface, you also have always the ability to run raw SQL statements. Because under the covers, there's also a connection, and you can do your statements, and you can do prepare statements, and then basically act like you would usually when you are working with direct SQL statements. So this gives you essentially the idea of how I can run define my data types using strongly typed objects in Kotlin, and then use Exposed SQL language to run SQL without having to do any kind of string manipulation or use strings in my code. But I told you that there's two ways in which you can use Exposed, and the other one is data access object. So with the data access object, we start pretty much in the same way. We don't have to change anything when it comes to table definitions. So in this case, for instance, I have organizers. Again, it's similar to before. I have an organizer object, and I have, in this case, an int ID table, which is what I was mentioning before. Before, I had a table, and then I would define the primary key. This is a shortcut to say, okay, I have a table that's got a primary key that's an integer. So I don't have to do that explicitly. I define my column names, which is name and the company size. And we have another object, which is the conferences. So in this case, I have a start date, end date, name, attendees, and the organizer is an object, again, that references an actual organizer. Notice I have the date columns here. So Exposed supports either Yoda time or your Java time, or you can work with Kotlin X date time. If your application is purely Kotlin, if you want to go multi-platform, you probably want to be using Kotlin date time. While Exposed itself isn't currently multi-platform, that is something also on our roadmap. But generally, date time, if you're purely Kotlin, the Kotlin X date time library should be sufficient for you. So far, it's exactly the same as we saw before with the DSL. All I've done is define my tables. But now, how do I get those tables, those reads, instead of doing SQL, how do I map those to actual objects of data inside my application? So now I can have my classes. I define my classes, which are going to be used to map that information. So for every object, essentially, I'm going to have a the equivalent class that is going to be used to read, update, write to my data in my app. So here I have a class conference. You indicate what type of ID it has. It has an entity ID of type integer. It has to inherit from an int entity. And then it has a companion object, which is basically going to be used to create new instances of it, as we'll see in a moment. And then for each column, I just say var name by, and then reference the object and the actual column. This is a little bit boilerplate. Okay, so we go from no magic to boilerplate. But we want to solve that as well. So there's a couple of things that we're looking at there. One of them is from the tooling perspective, Alt-Enter in IntelliJ and say add my data class here. Or we're also looking at the possibility of doing code generation, but code generation that you can navigate to. So there isn't any magic. You can still see it and see the actual results there. So, but yeah, there's a little bit of boilerplate here. With the organizer, I do exactly the same. I have a class organizer that, again, maps to my object, as we saw before. So if we go to the inserts for, I think I have it. Sorry, basics. So again, here, the steps are the same. I do a database connect. I open my transaction. The logger is just so that we see what's happening. I create my tables. In this case, it's 2. You can pass in as many as you want. And then I say organizer new. And then I set the values of my fields. Right? So organizer is that companion object that allows me to then call new on it. I set the values, and in this case, I have an organizer, and then I also have a conference. And I can keep a reference to the organizer and then pass it over to the conference when I'm inserting the conference. So I treat them as objects. I don't have to worry about the IDs or the foreign keys or anything like that. And again, we can run this. I'll just so that to prove to you that this works, I'm going to delete organizers and conferences. And let's drop this. Now let's run this. So you see it creates the table. If not exists, it's issuing that statement. It creates the organizer table, and then it inserts the values. And if we refresh here, we can see that we have our organizer, and we have our conferences, and we have our organizer there. So that is using essentially exposed, but instead of using it as just pure DSL, now I'm doing the mapping, and essentially I have a lightweight DAO. Now that lightweight DAO does allow you to do many other things, as we'll see. So if I want to do, for example, updates or deletions, let's go and say delete. Much the same way. I can say conference find, the name equals Australia. So again, we go back to using the DSL that we saw before. Obviously, this can give me back many, because in my case, for instance, I don't have uniqueness on that column, so I can get many results back. In my case, I'm just going to say find the first one and then do a delete on it. If I want to do any kind of updates, I can, do the same kind of thing here. So here I have, for instance, I'm creating a bunch of entries. So I'm creating NDC. It's got 2. Over there, so let's go ahead and create that, and then what I'm going to do is do an update, right? So you can see that I insert an NDC Australia with a date of 7th of November, and then I'm going to update it to the 8th, okay? So running this, and we can come to conferences, refresh it, and we can see that the Australia is set to the 8th. Isn't it nice when things work? So, again, conference is new, and then how do I update it? Well, I find the instance, it gives me back an object, it's done the mapping for the values, and then all I do is basically set the new value. And as long as I wrap that in a transaction, then it's good to go. It does check for things like, for example, as I said before, transaction by default is it's defaulting to a default database. If there are multiple databases, you won't be able to get, one object from one database and update it in the transaction of another database. It obviously does some checks there for you. But the idea is to really kind of like eliminate all of the tedious work that goes in regards to working with data in that regards. And then, as I said, you have many possibilities, no pun intended, of doing many things with exposed. So even if you want to do like many-to-many relationships, you can do that. In this case, I have a Star Wars film that has actors, and an actor can be part of many Star Wars films. So we define basically actors by actor via Star Wars films, which is the many-to-many table. And in this case is the Star Wars film and then the actor and then the primary key, and then you can manage many-to-many relationships there as well. So you have one-to-many, many-to-many, singular relationships, etc. So we've seen kind of like the DSL stuff, we've seen the DAO stuff. What else is there to see? Well, first of all, before we get to the real world example, here's a situation that is going to not work, right? If I call transaction and I say some async op, that's not going to work. Why? Because some async op is a suspending function. And while any transaction that you execute and exposed is synchronous, it's not asynchronous, it is synchronous, it is blocking. That means that every time I make a call, it is going to block. While that is blocking, if I want to use this in an application that uses suspending functions, it's not going to work. So in that regard, what we do is we've defined a new type which allows you to have that bridge, which is called new suspended transaction. Now, you may ask yourself, Hadi, why did you call it new suspended transaction and not suspended transaction? Well, because there is a suspended transaction. Now, why aren't you using suspended transaction? Well, that's because when you want to nest. Why aren't you calling that nested? As I said, we need to review the API. Okay? Not everything I show you here is justified. It does need some cleanup. But this new suspended transaction allows you to have that bridge when you want to work with suspending functions, and we'll see that in a moment when we take a look at a real-world example using Ktor. By default, also in exposed, everything is lazy loaded, right? So that makes it a little bit more efficient. But if you want to do eager loading, especially when you don't want to end up, the typical select n+1 problem, you can essentially find the object and then say load, and load all of the column that is a relation that is another table. You can load that and it will prefetch all of that for you. So that makes it, again, more efficient when you're working with iterations over data. Now, what about dealing with migrations? So we've seen that I can basically recreate a table. I can recreate it. When it recreates it, it checks to see if it exists. If not, it will recreate it. But what about migrations? There is none. There's no support for it right now, currently. So you have multiple options here. One of them is using Flyway, which is a de facto that is provided for working with databases. The other one is using schema utils and basically doing it yourself. Kind of like create, drop, create missing column, etc. Most likely, though, however, we will be working on adding migrations to exposed to make it simpler for you to do migrations of your data. But right now, if you want to do migrations, you're going to have to either use a third-party library such as Flyway or essentially run it yourself. So let's see how this works in the real world. How many of you use Ktor? Okay. Ktor does have a website. Ktor is simple and fun. It's also, wait for it. Yeah, there you go. There you go. You see, it's lightweight. I'm involved in Ktor as well. That's why the whole lightweight thing, everything that I'm involved in is lightweight, except me. So, yeah, Ktor is basically like an HTTP server and client, which allows you to write server-side applications. So if you've worked with Spring Boot, it's kind of like that. If you've worked with Quarkus, similar to that. It's built again from the ground up using Kotlin. It's heavy on coroutines, and it's built and backed by JetBrains. It's there, I have to say it. So let's take a look at an example of combining these two things in the real world. Now, before I get into that, let me just go back here because I wanted to show you something. One question you may be asking is, how do you test applications with exposed? And this opens up a whole philosophical debate, right? Because how do you actually abstract your ORM or your DAO? There's two schools of thought. There is the school of thought of, I want to use an ORM to have an abstraction over a specific type of database. So I want to be able to abstract over Postgres and migrate to MySQL, and then migrate from MySQL back to Postgres, kind of like what Uber did. Or I want to have that, and in addition to that, I want the ability to swap out my ORMs. Okay? Now, I've been in software development for 30 plus years. I have worked with a variety of ORMs. Do you know how many times I swapped out my ORM? 0. Right? And yet every time I started a new project, do you know what I did the first thing? Abstract my ORM. So there you go. You do whatever you want. Some people want to abstract their ORMs, some people don't want to abstract their ORMs. The sample I want to show you is abstracting the ORM. But that brings you to the point of testing. How do I test my stuff if I don't abstract my ORM? How do I do all of this? This is crazy. So testing. One thing you could do is use test containers. I don't know if anyone's used test containers, but independently of whether you are abstracting or you're not, when you want to test your database, I recommend you use test containers. Test containers is basically a library that allows you to easily start up a Docker container, run the test in it, destroy the Docker container, and away you go. Why? A lot of people say, why don't you just use in-memory? Especially with exposed. Exposed allows you to use H2 in-memory databases, so you could just flick a switch, use in-memory for your test, and then flick a switch and use Postgres. Why? Because at the end of the day, there are subtle differences between H2 and Postgres. And if you're testing your application, you should test it with the same thing that you're putting in production. So I would stay away from the memory stuff. I would use test containers. With test containers, it's very, very simple. You essentially create a container. In this case, it's a Postgres container. I tell it the Docker image. I know this is wrong. I feel like I'm in the JavaScript camp now. I just use the latest version of everything. With database exposed test, with username exposed, with password. Okay, and that's it. I essentially just run this, and very quickly, it is instantiating a new container, running it for me, running the test, and shutting it down. Right? Obviously, the first time it takes a little bit longer, but there you go. Done. So it's actually created a container, initialized the database, created the database, shut it down. Much better way to do your testing. Now, coming back to the real-world application, here I have a Ktor website that essentially what it's going to do is like a blog. It's how blogs should be these days, right? None of those fancy things, just a really nice, simple blog. So I can say create article, and I say Android makers giving a talk, and submit, and go back to the main page, and I can see my Android makers, and I can edit the article, Android makers 2023, update, go back to the main page, etc. You get it, right? It's essentially just interacting with a blog. So what's this? How does this work under the covers? Well, first of all, for folks not familiar with Ktor, imagine that it's basically an HTTP endpoint that you can go to different routes and do different things. So when I call on the index, essentially what's that doing is rendering all of the entries of my database. When I say articles, it's going to show me a specific article. When I post, it's going to update the article, etc. This isn't code that we're interested in. This is very specific to Ktor. Let's just go to the simple one, which is just listing articles. So here I have this DAO object, and I have all articles. So my DAO is essentially a facade over, this is the implementation of my DAO facade, right? So you can see it here, which is a bunch of functions that then I implement, and these are suspendable functions. So my facade is essentially implementing each of these, and all it's doing is calling delegate articles. And what is delegate? Delegate is the actual facade, which does the implementation. But the thing to look at here is when I go to sorry, where am I? Oh my God, routing. Why isn't it there? Oh, I was down there. Right, so when I go to the articles, the implementation, yeah, which is what we saw here, is going to have to wrap the stuff in some kind of transaction and execute that transaction, because it can't just get all articles as we saw before. It has to do that in the transaction. So we've defined a function which is called dbQuery, which essentially does that for you. And here you see this new suspended transaction that I was talking about. So what this does is basically take the IO dispatcher, which is the default dispatcher you want to use with Kotlin coroutines when you're doing IO work, and it is executing the block of code that I'm passing to it. So that would be whatever I'm wrapping in that transaction, that is what I'm passing to it. And if we take a look at the usages here, so for instance, when we go to the all articles, you can see that here I'm wrapping every exposed call that I'm making in this DB query. So I'm wrapping it in this suspended transaction, I am executing it, and I'm returning the results. And this is essentially what we saw before when using exposed, right? This is the select all comes from exposed, the map all comes from the standard library, and then I'm returning the results. So the point being that you don't have to worry about passing the database, you don't have to worry about starting any new transaction all the time, dragging the transactions around. All of that you can wrap in a function and then wrap your functions inside of that and essentially do functional programming, because that's what functional programming is, right? It's essentially the idea of using higher order functions to, you know, abstract functionality away. So very simple to use, and if you want to now, if you start a new Ktor project, it's even easier. You just click next, and we have plugins for everything for Ktor. And one of the plugins that we've recently added is exposed. So you just click add, and it says, oh, you need exposed, you need all of these other things as well, done. And then it will create for you all of the setup and all of the code that's necessary for you to basically start working with exposed without having to go away, I won't see that. To work with exposed, I know, yeah, okay, fine. I don't want to analyze memory. To work with exposed. You have exposed things I didn't want you to expose. Oh, very funny, Hadi. Right, so what is our plans for exposed after this? Well, first of all, as I said, exposed is a 20% project by one person at JetBrains. However, we have now hired a team around exposed. We have now two full-time developers. We're putting in a process for creating releases often. We're creating new documentation, we're creating a new website, and we have a roadmap with a whole bunch of functionality in place. We're already resolving many, many outstanding issues that were on GitHub. We're going to be adding support for asynchronous. We're going to be adding multi-platform support, composite keys, and many of the other highest voted issues on GitHub. So all I'm saying is that it's safe to use exposed moving forward, although it was safe to use before either. It was safe to use before also. So yeah, there you go. If you want to learn more, for now, you go to github.com/jetbrains/exposed. That will eventually be redirected to our website where we will have more information. But there's more or less enough for you to get started there. There's a wiki which has some documentation on getting started, etc. Okay, and with that, we're done. Thank you very much.